To compete in the race, it takes nothing less than a brand new train. However, it must comply with two requirements. It has to be 100% electric, so that it doesn't depend on rising oil prices, and it must be able to run at very high speeds every day. Yet the engineers don't have to look far to find the answer. All it needs is the TGV with a new formula, without its helicopter turbine and re-equipped with a pantograph. In other words, a TGV 2.0. It's the one we know today, a train imagined almost 50 years ago. Yet to run it at 250 kilometers per hour every day, there is an obligation.
There has to be a difference of 150 to 200 kilometers per hour between the record speed of trains and the commercial speed.
If you want a train that runs comfortably at 260 kilometers per hour and well within safety margins, you have to prove that the train can go over 380 kilometers per hour without any problems. The margin is required to reassure not only the officials, but also future passengers. So once again, the race is on. The bar is set at 100 meters per second. The project is christened TGV 100. To prepare for the new speed record, not only will the train be profoundly modified, but the track too. Since the electric current coming from the power stations is going to jump from the traditional 1,500 to 25,000 volts. To guarantee such a powerful electric current all along the line, you have to build substations at a distance of 50 kilometers. These small bases will adapt and reduce the gross power sent by the central station. For the high-speed line between Paris and Lyon, control and management of the substations is done from Paris. Here they check that the intensity of the power supply from the small copper wire is constant. The catenary receives a current 20 times more powerful than before. But it also must be adapted to the specific conditions of a record run, because the engineers anticipate a problem. The pantograph, by pressing on the catenary at high speeds, will create a ripple in the copper wire. It's a phenomenon dreaded by engineers. If the pantograph catches up with the undulation, it will lose contact with the copper wire and only hit it intermittently.
If you tear off the catenary, it means disaster.
So how do you make the catenary lift as little as possible and stay in constant contact with the pantograph?
On a high-speed line, the catenary is stretched to 2,600 decanewton. That's almost twice the tension on a conventional line.
The counterweights on the masts are increased to further stiffen the structure that holds the catenary, an indispensable process. The infrastructure on the ground is modified too, since the old 30-meter rails cause a shock each time the train passes over a weld. The whole system is therefore redesigned.
We now manufacture rails that are almost 300 meters long and are delivered by special trains.
These bars are assembled using a special technique. They're welded with aluminium.
The result is a rail without any intermediate mechanical joint.
The disadvantage of extremely long rails is that when temperatures rise, they tend to bend upwards along their entire length.
So we chose very heavy rails, weighing 60 kilograms per meter, so they won't lift.
With a target speed of 380 kilometers per hour, the infrastructure around the train has been rethought to correspond to the laws of physics. Yet no rail-bound train has ever approached the speed of the record envisaged. It's a leap into the unknown. The whole country has its eyes riveted on the record attempt. It's like launching a rocket in the horizontal. The tension mounts. In the car behind the driver, there are engineers to observe and retrieve the information provided by the train itself.
Même pas 2 tonnes 4, 2 tonnes 1, 2 tonnes 2.
Of course, the train was loaded with sensors, as during all the previous runs.
On February the 26, 1981, the TGV 100 gets rolling. For conductor Jacques Ruisse, going for the 380 kilometers per hour is beyond anything he's done before.
In the cabin, you have a threshold at 170 where you can see the train's accelerating. Then you have another one at 210 and again at 280.
However, Jacques Ruisse is not alone. Engineers and managers are present to assist the driver.
On the photos, they tell me I look tense. But when you're going that fast, you can't let yourself be distracted by people in the cabin.
120 seconds. 372 kilometers per hour. 73, 74, 75, 76, 77, 78, 79, 80. We've reached 380 kilometers per hour.
380 kilometers per hour. The world record of 1955 is beaten, but they can't go any faster. Due to the force of the airstream, the pantograph lifts off dangerously from the train, pushing the catenary much too high.
We already had a lift of more than 21 centimeters, so we stopped at 380.
The limits of the TGV 100 have been reached. Yet the performance is unprecedented, with a train and installations that will be used in everyday traffic. It's state-of-the-art technology at the service of passengers. This train is not a utopia, it's the very train that will race into the future.
The interesting aspect was that we were breaking records with commercial equipment.
The world record makes the TGV a worldwide success, and the lines spread all over France. The high-speed train becomes the new icon of the railway. Passengers are eager to board the orange train. But like all records, this one too will be hunted down. 7 years later, on May 1st, 1988, the German manufacturer Siemens sends its ICE between Hanover and Würzburg at 406 kilometers per hour. France loses its title. It's a blow to the nation's pride. At the manufacturer Alstom, there is only one goal now, that of overtaking the Germans. All forces are going to focus on this objective. The commercial future of one of the jewels of French technology is at stake. They must strike hard this time, so as not to be overtaken again a few months later. The aim is to crush any hopes of being on an equal footing with the French railway industry. The envisaged speed must kill off all competition for a long time to come.
We were hoping to break the 500 mark.
500 kilometers an hour, a mythical barrier. Yet how are the engineers going to achieve this feat? Will they be able to improve the rigidity of the catenary so that it won't be torn at over 380 kilometers per hour? And what are the new constraints at that speed?
At 600 kilometers per hour, an Airbus is well into the air.
Again, they have to push the limits of the train and work on its body of steel. Since during the previous record, at 380 kilometers per hour, the sides of the train began to erode.
The bay windows protruded slightly from the sheet metal, so the higher the speed, the more they were exposed to the air rush. And we're talking about sheet metal just a few millimeters thick.
With an imperfect airflow, everything that protrudes is gnawed away.
So when the train's underway, there's a continuous abrasion of 3 to 4 hours.
The effect is a real break on the train, so the fuselage has to be perfected down to the last millimeter. For the first time, rubber membranes are placed between the cars. The designers work on the aerodynamics of the first car, but also on the tail end of the train, so that the air will flow without too much rupture. Metal shields are placed on the bogies to prevent the air from getting inside. The diameter of the wheels, which is traditionally 920 millimeters, is increased to gain speed. On top of the train, the pantograph is put on a firmer suspension so as not to lift the catenary, as happened during the 1981 record, when the copper wire had been pushed up about 20 centimeters. It's tightened once again to ensure the closest possible contact with the bow. But it's not only the train that is modified. The infrastructure is also adapted. The line is secured by 2 to 3 meter high fences all along its length to prevent accidents involving animals crossing the tracks.
Game struck by a TGV at 300 kilometers per hour causes a lot of damage.
But fences may not be enough. There's also surveillance along the tracks.
There are some hunters and hunting federations with whom we have partnerships, who will hunt game along the line or try to scare it away.
Everything's ready for the record. But before they invite the press from all over the world, a number of high-speed tests will be performed. Several times the train approaches the 500 mark.
We were gradually increasing the speed, and each time we'd monitor all the data to check that we were still within a safe margin. Then, on May 18th, 1990, we told the top brass, "Okay, we can go."
The public holds its breath as the record attempt is covered live on television. Are the engineers going to win their bet and exceed 500 kilometers per hour on rails? Nobody has ever done it. Suspense is total.
Speed 494. Passing Vendôme Station in a few seconds. Passing Vendôme Station. Speed 495.17.
Just a few kilometers per hour away from the magic 500. Yet anything can still happen. The catenary may rip. The pantograph may be torn away by the speed. The engineers on board scrutinize the reactions recorded by the sensors. Anxiety and excitement become one until the delivery.
500. 514, 15, 515 point something. I'll read out later. Cut all tractions. We're watching. It's not over yet.
After being held for 2 years by the Germans, France recovers the rail speed record on May 18, 1990. The German interlude apart, France has held the world record for the past 36 years. The TGV brand has re-established itself and is exported all over the world. 16 years will pass until in 2006, the railway engineers roll up their sleeves once again. France's state railway is preparing the opening of a new line between Paris and Strasbourg. A new speed record on this track will give it an exceptional boost. The new track offers 200 kilometers at high speed, with a straight section of more than 40 kilometers and bends with comfortably large radii. The V150 project for 150 meters per second has been born. And again, there'll be a new version of the TGV, a real supertrain. It's the AGV, the Alstom high-speed train with new motorization.